Hello, everyone.
Hi.
Welcome to ITS 140. Okay, so I graded your first homework assignment, so hopefully you can see that. If you haven't done so already, please check. A few comments about this, about the homework. So they looked okay, they look good. The one thing I noticed is that some of you were creating multiple reports, or they were giving me multiple folders, and I have to look for things. Please, for future homework assignments, just submit one single report, okay? So put everything. So what I want you to do is either in PDF or Word, do problem 1 and then put the flow chart, the pseudocode, and the code with screenshots of it running. Then do problem 2, same thing, put problem 2, you would put the flow chart, pseudocode, code with it running, and so on. So do that in just one single report. Otherwise, everything is fine. Everything looked good. I've graded your first homework assignment. I'll get to your second homework assignment in the next week. And then you have a third homework assignment that's due this Thursday, right? The functions and modules, basically. So at this point, we haven't really done that much. Or is it the if statements? Is the if statements the one? Can't remember. Can you guys remind me so the if statements, that's the one that you submitted last Thursday?
I think so.
Yeah, conditional structures, right? And then you did modules and functions. Yeah, I think that's how it is. And then modules and functions this week. And so that's where we are. So are there any questions about homework number 3?
Did you want us to resubmit it if we put multiple Word documents?
If you did it for just going forward, so for the next homework, do it, don't resubmit it now, but for the next homework, the one that's due this Thursday, do one report, please.
Right.
Yeah. Any other questions?
Wait, can you please repeat that?
Repeat everything I just said. So what I mean is, some people are doing a problem and they put it in one folder, and then they put the Word document in there and they put their code, and then they do a second problem and they create another folder and they create a second report and they create a second script. So what I want you to do is, you can do that for the code if you'd like, but for the report, I need one single report. So usually what we do is, we store your reports and we put them up, and you need to be able to reference the entire homework assignment in one document. Okay, so you can continue to create multiple reports if you'd like. You don't have to, but what I need though is I need one single report, either a PDF or a Word document that will have problem 1, this and this. So here's the pseudocode, here's the flowchart, here's the code running, all in that document. Then in the same document, problem 2, flowchart, pseudocode, code, and so on. Does that make sense?
Yes.
All right. Any other questions? Any other questions, guys? So are there any problems that you would like me to work on right now? Or otherwise, we'll just move on to the next topic. But it depends on the class, right? So it depends on the class, and I will pace the class based on, what you kind of want. So if you want me to work through another problem of anything that we've seen, I could do that. Otherwise, I'm just going to assume that everything is very clear to you and that you want to just keep going with new material.
Can we ask a question on any other homeworks?
Yeah, you can ask a question. Yeah, go ahead.
I had a question on the Roman numeral one.
Okay, what was your question?
So how I did the Roman numeral, it was like I made a module and I was like, if x equals 1 to 10, display that Roman numeral.
Mm-hmm.
And then that was like my module for it.
Okay.
And then it wasn't.
So that was 4-1. So you just kind of want to see how to do it? Is that what you?
Yeah, I just kind of see how to do it. Cause it displayed, but I had another question and I can't remember.
Uh-huh. What's your question? Are you still there?
Yeah, I'm still here.
So am I.
So
I'm just
you want me to, so I believe you're talking about programming exercise, Roman numerals, design a program that prompts the user to enter a number within the range of 1 through 10. The program should display the Roman numeral version of that number. If the number is outside the range of 1 through 10, the program should display an error message. That's the one?
Yeah.
Okay, so let's do that one. That's good. Let's go ahead. And that's kind of what I mean. It's that we really don't have to rush. Okay, we don't really have to rush. So let's do that one. Let's try it out. So let me switch over to the whiteboard. Okay, so I have some questions on the chat, and these are questions that some of them I've already addressed. Do we need to have a report for each lab? Yes. Lab assignment, but not per problem. Okay, so you don't need actually, I don't want, honestly, a report for each problem. Okay, it slows me down to have to open all these reports when I'm grading. It's not practical for saving your materials either. You can have folders for the code if you want, that's perfectly fine. But I just want to open one lab report and everything should be in there. As I said, screenshots, your flow chart, your pseudocode, your code, screenshots of it running. Or do we just submit the code? Do not just submit the code. You need to submit, if you submit the code, right now I went easy, but if you just send me code and I think I said this before, if you just send me code and I don't see a screenshot of it running, I'm just going to assume you didn't get it to work. Okay, so don't do that, please. You need to show evidence that something worked. If it didn't work, you need to show that as well. So then I will look, and that's why I recommend when you submit your Python, your Jupyter notebook, is I can quickly look at it and correct what it is that you got wrong, and if it's a small correction, I may just give you all the points because I'll say, oh, it's just like a little typo type of thing. If it's a serious logic error that you just didn't do it, that's different, right? So don't think of what you submit as, do I have to? Think of it in a different way. Think of it as, how will it benefit me if I do these things? So if you submit one lab report, I can grade things a lot easier and faster to you. So you want your homework faster. That's one. If you put screenshots in there of your code running, you're telling me, you're convincing me immediately that you did it. If you put your Jupyter notebooks in there, you're facilitating my ability to find little errors and just give you the points. But if you don't do these things and you make me struggle to find things, right, in your documents, then it's, I may miss it, and then you're going to miss the point. So the way that you should think about this is you should think about it as, if I submit this and this and this, it's going to help my grade in the end because the information is obvious and there's no way that I can lose points. So that's really how I would view things. So definitely please submit just one lab report. Do not just submit code. That's a bad sign. Usually, I know when students didn't get things to work when they just submit the code, and that's not something you want to do. All right, another problem is, yeah, so I'm going through a problem right now. Bring up the problems, please, if you have one in question, in mind. That's actually a good, somebody says, I can't seem to get something to work, and I just copy and paste the code. Sure, let's do first the Roman numerals, and then please speak when I'm done with that to remind me, and then you can paste your code so I can look at it, look for it on the chat, and then we can all work on it together. Okay, that sounds like a good idea, actually. So we'll just take today, I think, to catch you up before we move into for loops, which are certainly more challenging arrays after that. And so I want to make sure that these chapters are clicking a little bit more with you guys. So, I was going to switch over to all this time I've been on the black screen. So let's switch over to the whiteboard over here. And we were doing the Roman numerals. Now, so whoever asked for the Roman numerals one, what do you want me to do about it? Do you want me to go over the pseudocode? Do you want me to go over the flowchart? Do you want me to go over the code in Python, the Jupyter Notebook? What do you want me to do? Hello, whoever asked for this? All right, so pseudocode and Python. Okay, so let's go over. So usually in Python, I will just use elifs, but in the pseudocode here, I can't remember honestly a time when in Python I use cases or anything like that. So it's gonna be the elif, but maybe in the past Python had cases, but for the longest time, I've always used if. Yeah, Python does not have a switch case. And then what you're supposed to use is like dictionary mapping or something like that, but we're not going to do that. That's a little bit more advanced. So instead, we're just going to use, elif, but here, let's go ahead and do I think he said the pseudocode. So this is problem 4.1. 4.1. All right, and this is the Roman numerals. All right, so this was modular, I guess, a little bit, right? So we're gonna do module main, right? And then we really just need a number, honestly. Declare integer. And then we create the variable number, right? And then we're gonna call get number. And that's gonna be a function that we can use. Yeah, unless, actually today I'm going to take another approach since I haven't used this that much. And given that you don't really use it much in Python like this, but let's do it. So I'm going to assume that this is a variable in memory, integer, right? And I'm going to actually use by ref. All right, so I'm just going to say, you know, I have number there, number. So we will need to have some way of linking this inside the function with that, right? So we're going to need some way of doing that. And the by ref actually does it because it's like pointers to or addresses, let's say, to the same place in memory. I'm also going to use a comment here, just, you know, kind of illustrate this a little bit more. And I'm going to say display Roman numeral. Oops. So Roman numeral. All right, so then we have a select here, select, oops, that does not look like select. Select, and we're gonna give it the number. All right, so select number. And then now in the case statement, we would do case 1, colon, and then that just indicates display 1. See that? Then we do the other case 2, and then we do display 2. We can do case 3, display 3, right? Assume we continue over here, and I'm not gonna do all of these, but let's just say case 4, display 4, and then let's just say dot, 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 case 10, display 10. And then there's gotta be an else, you know, statement or a default one here, you know, call it default, and it's gonna be display error, or, you know, invalid number, or whatever you want to say. Then, because we opened the select, right? We opened the select, we need to close it. So then I'm going to say end select. And then the module over here, we opened it, so we want to close that as well. And so I'm going to say end module. All right, and then the only thing that we need to define now is call get number. So I'm going to do that in the next page. And so I'm going to say module get number, get number. Now here comes the trick, is that in here we have to say integer ref. And by saying that, now we are linking both variables, you know, by ref, by reference. So number. So whenever we make it's like whenever we make a change over there, we make a change on this one, right? And so that's really the idea. Okay, so we did module get number. All right, so we do integer ref sorry, change that. Get number, integer ref number. And then now we do display, and then you do enter, you know, an integer from 1 to 10. Okay, and then we do input over here, input number, right? And then we do end module. So just keep in mind that this number, you know, when we do that, it's linked by ref, which means it's also linked to the original program there, right? And so by making that change, then this one references that one after it's been changed from the call, and so we basically get what we need. And that's it. So was it Temi? So does this answer your question about the pseudocode?
I didn't actually ask the question, but yeah.
I asked the question, but no.
Oh, who asked it? I'm sorry. I guess someone. What's your name? Whoever asked the question.
I'm Keelan.
Oh, Keelan. Okay, so this is what you asked, correct? This is.
Yes.
And so is this clear for you, or?
Yeah, I understand.
Okay, you understand. Okay, great. So do you need me to do the Python as well?
Yeah.
Okay. All right, so now let's go ahead and do the Python. So we're going to open up the Jupyter Notebook. Okay. Okay, so all right, so then we can switch over to the Jupyter Notebook here. All right, so I'm going to close this one. Jupyter. Okay. Okay, so I'm going to switch the screen. All right, so you should be seeing now the Jupyter. So I'm going to create a new file here on 3. All right, so this should be in, if we do this in Python, as I said, I'm going to use the elif statement. I kind of like to do things, you know, a certain way. So let's see. Let's see. I don't. Well, let's see what I need. So what I'm trying to say is usually when I program, I just start with something and see what I need. So I don't have to actually start writing a whole bunch of variables and things like that. So I'm just going to do get number. I'm going to start there. All right, I know get number does not actually need, and then, oh, parameter, colon, yes. All right, then I'm gonna do print. And I'm gonna say enter an integer from 1 to 10. All right, so I do that. Then I'm gonna have my input. So I'm gonna say input number, right? And I'm gonna do the input. Remember, this is a string, so we need to do the typecasting. So it's gonna be, you know, just like that. We can do the float if you'd like there. You can do it separate. You can say number You don't have to do this. You just could float, or actually it's an integer, right? Doesn't matter. They're all integers. So integer input number, right? We do that. And then we need to return number float. Okay. I like to add lines, just my own style of doing things. I'm also going to do define main. You don't have to do this, but you could. And this is going to be the if statement. So the main needs to take, so let's say I'm going to put an if there just for now, and this needs to take as an input. And then over here, if I do something like that, I need to call it, right? So I actually had a student ask me a question about this. He had everything correct, except he forgot to call a function. So I'm going to plug in here number, but before I do that, I need to get the number. So I just do get number. All right, and that should then get the number, assign it to number, and then we put it in main. So now we are basically ready to go, I think. So if number equal 1, then I'm going to print the Roman numeral. Elif number all 2 print and so on, right? So then we can just copy this and modify it. So I'm going to do oops. So let's see, this would be 3. So this needs to be 3. 1, 2, 3. This would be 4. This would be 4. Oops. 5. 5. 6. 6. All right, and then probably 4 more of these. Okay, so this is going to be 7. This is going to be 8. Okay. 9. Okay, and 10. All right, and then the last one is just a catch all else. Print, print, and then we're going to say, you know, invalid number. And that should be it as far as if I got my indentation right, I got my if statement right, everything should be there. So let's go ahead and try this out. So 3, and there it is. Are there any questions about this, guys?
Nope.
Make sense?
That's exactly how I had it.
Good. There you go. Great job. All right. So someone else had then a question about some problem they had. So you were going to put it in the chat, I believe. All right. So there it is. Seems. All right. Paste it in there, please. Well, while he's doing that, are there any other questions? Any other problems you want me to work through, or?
I think we about to have the same question. I think he's talking about question 2 of the newest homework. So I think David, the guy who put in the chat, because question 2 of the new homework is they kind of wanted to revise the sales tax code we had from like chapter 2.
Okay, so you want me to, okay, so then I think he just pasted the code. So that this is what you want me to look over, correct? Yeah? Okay. I don't know, the other person that was talking, I didn't quite understand what you get. But this is, I thought I saw this code before.
Yeah, we did it in chapter 2.
All right, so let me,
They just wanted us to like add on to it, make it like a module.
mhm. And it's not working, you say? I'm trying to copy it, just give me a second. Okay, there it is. All right, can you guys see the Jupyter notebook and the code?
Yes.
Okay, so what is the question? What's the problem? It's not running. Is it that you want to add something else? What's the issue? David, it's your code. So you tell me what? It's not running fully. Okay. And okay, so it gives an error.
Yeah, it won't show me like the total sale or like the total tax. That's what I'm trying to get to show, but
Show state tax, county tax, and then you're saying total sale is not working, correct?
yeah, and the total tax is not showing up either.
All right, so let's go through it then, line by line. So I'm gonna you start at main, then main amount of purchase amount. So that worked. All right. State tax. You give it amount. Okay, I see what's going on here. All right, so this, you don't want to do that because you're not printing, you just return the values. You need to use those values as float, not convert them back to a string. Country tax then takes amount as well. Yeah, same thing.
So I would just take out the print.
Mhm. You can print it later after you do your operations, but while you're doing calculations, leave everything as float or integer,
Okay.
depending on what you're doing. Then you have total amount of tax where you take state tax and county, or I think it's county, not country. All right, then you would say, these are two numbers because they would be float. So then you can add them and it would give you amount of tax, but again, you get rid of this. Okay. And then that returns amount of tax, okay? And then you take amount of tax and amount. So you add amount of tax plus amount to get total sale. And again, get rid of that. Okay. And then now you get total sale. And then which value is it that you need to print? All of them or just total sale?
Yeah, I think it's all of them.
All of them. So then you could just here do print. You could also do it in every function. I mean, it's either way, but state tax, and then you would do this. You see that? And then you repeat this for the other one. So I don't think I need to do it for all, but just let's do it. I did that one, and then I'll do the last one, total sale. Total sale. All right, so that should be the solution. So it should print state tax and total sale. Run it. All right, and that should be it.
Okay, so I just had to add the print statements in the main.
Well, you had print statements and these returns, right? And
Yeah.
here, by doing that, that's really what was causing the error. So just return the variable as a float or integer. Don't put
Okay.
it out. Okay?
Yeah.
That should be it.
Yeah.
Good questions. Are there any other questions, guys? Anyone else want me to do another problem? No? No more problems?
I have a problem. Question 3 of the current homework.
Question 3
Of the how much insurance. It's on the latest homework. Where
those. Okay. Question 3 of the programming exercises. What is that one?
how much insurance?
Okay. What's your question?
My question was, so do we have to have the program figure out what 80% of what the input has to be? Or should we just input like 80% and just put that into our module?
But what if I don't want 80%, I want 67%? Then you have to do that again with a calculator, right? The whole point is the program should just do it for you.
Okay, that was my own question.
Okay. Anything else about it? No? All right, so what I can do with this one is I'll let you guys do the flowchart and the pseudocode, and I'll just do the Python code for this one. And then after that, there are no more questions. We'll get started with, the for loops chapter. So let's go ahead and do one more example here. All right, so this one's 3-3, right? So, you know, here you can do, you know, problem 3-3. Okay. So the idea with this one is, as you said, you have a 0.08. You have a replacement cost that you have to read. You have to calculate the insurance amount, and then you display the information about the insurance. So the replace is basically the replacement amount. Do the calculation, which should be pretty straightforward. Okay, so it's very, very, very simple. So let's go ahead and look over it in Python. So I'm gonna do, let's start. You can start this in various ways. You know, I'm doing this right now. I don't know why. Let's do this. I guess to be consistent with the book, let's have mains in there. All right, and then I'm gonna do main. All right, and the first one will be to call a function that we're going to call get replace. So we're going to get replace. All right, and I'm going to have another function in there called set insurance. And I'm going to have another function in there, show insurance. Okay, so I have those three in there, sort of what I need to do. Now I'm going to have another one. So let's start with get replace. All right, and in get replace, you know, we're going to read in the data. So I'm going to do print and placement amount. And then we're going to do replacement amount. I'm creating a variable, input, and then I'm going to return this input. Just like that. So that's the first function. Then after that, I'm going to do the calculation. So set insurance, define set insurance. Now this one, because the previous one returned, now I have to make a change to my main, and I'm going to say replacement insurance. Notice that usually I could use the same names, but I have a tendency, just for sanity, to always name variables with different names. Okay, I do that just for my own, to make sure I don't make mistakes. As you will figure out in programming, you have a lot of preferences that you follow. And you get into work, you know, habits. All right, that just are within your comfort zone. All right, so now I have rep insurance. Okay, so I did that, colon, set insurance then is set insurance will be what? Set insurance will need to have a variable. Call it insurance. Insurance. Okay. And then in here now we need to perform the calculation. So we're gonna do replace insurance. Now, if you notice, there is a variable for the percentage. That would be what I usually call these. I don't call these global variables. I'll know in the book they're called that. I just call them parameters, right? So every program has a set of parameters. So in this case, I'm going to do replace. And notice that it is uppercase. And again, it doesn't have to be like that, but it's just a practice. So replacement percent equals 0.08. Okay. Given that, then I can use that within my code by just plugging in a second parameter. So now it's rep insurance and replacement percent. And then I can do the opposite. So I need this one. Okay, something like this. And then now I could do this in a lot of ways. I don't want to write more variables. So I can just actually do the whole thing here. So I'm just going to do insurance times, remember it's case sensitive, so replace percent. All right. And that's it for that one. Then, you know, I put in, just to make my code very clear and readable. I don't like spaghetti code. I like things to be very well formatted. And then after that, I'm going to do the last part, which is to just print out the results, show insurance. Show insurance needs to have whatever is returned from set insurance, which is total, let's say, total results, right? Something like that. We're going to plug that into show insurance. So now we need to create, and you can also sometimes just copy these things, makes your life easier. Define show insurance, total result, colon. And then I think, I'm not going to print everything out. I'm just going to print the final result, which should be print total insurance result is in dollars, right? And then you can just plug in total result. So they're going to basically give you 80% of your replacement cost. So let's say it's a car and it was $10,000, it should give you $8,000. That's pretty much the idea. So let's see if it works. All right, so now we're going to go ahead and run it. And I'm going to say 10,000 over here. Oh, gave me an error. Can't multiply sequence by non-int of flight type float. So what's my error? Who can tell me what's my error? Guys? Are you guys still there?
Yeah.
So what's my error?
Yeah.
Why did I get that error? It's an error we've seen before. You should know.
Are they thinking it as a string instead of a float?
Mm-hmm. Exactly. So then I'm going to go over here. All right. Let's run this. Okay. Did I not run it? Okay. $800. I thought it was 8,000. Oh, okay. Yeah, it's 8. Sorry, it's not 80. It's 8%. Okay, that makes sense. Questions? No questions. All right. Seems like there's no questions. It seems like everyone understood. So I assume then that everything is clear as far as the homework assignment that's due this Thursday, given that I'm not seeing any questions from anyone, right? And we've gone over several problems already. So given that, I'm going to start then the new topic. So we're going to get started with our new topic, which is for loops. Or actually, I should call them iterative structures. This time around, I'm going to try something different. I'm going to start with the Python Gaddis slides. And then I'm going to go to the general ones, given that now you have a little bit more background, right? You can probably shift it every now and then. I'm still going to cover both, and you still have to do the flow charts and pseudocode, but let's start here. So are there any questions before I begin? Also, what week are we currently on? What week is this? It's week 5. What do we have on week 6? Or what is scheduled for week 6?
An exam.
An exam. Very good, sir. So a week from today, next Tuesday, you will have your exam. Usually, if we were in school, we would have a written exam, but unfortunately, we can't do that right now, unfortunately. So I'm going to create a series of problems, and they're going to be similar to the homework, basically. So what I'm going to do is I'm going to open, just like I opened the homework link, right? Just like I opened the homework link, I'm going to open a Dropbox on that day from 12 to 2. The exam will stop at 1:40, but I'm going to give you that extra 20 minutes in case, students have problems with submitting things. The Dropbox will close at 2 in the link in Brightspace. You need to make sure you submit, because if you don't submit before 2, you'll miss the exam, right? So you need to be here in the session. I will just post. Let's just say I will be there for questions, right? I'll be there for questions, kind of in the background. And be ready, have everything ready in your environment. If you have several laptops, have them there in front of you, or however you want to do it. Obviously, it's open notes. I can't really Now it's not going to be problems from your book because I could, you could easily just have a solution or something and copy them. So I'm definitely going to come up with a few problems of my own. Given the time constraints, you can do maybe 3 or 4 problems in that period of time. So that's what you can expect. I'm going to have 3 to 4. I'm going to try to shoot for 4 problems. And what I might do is I'm not going to say, submit I'm not going to say submit everything of each problem, a flowchart, pseudocode. I might just say do this or that in particular. You might expect, so what I'm going to ask you to do is for the exam, you're going to probably, the easiest thing to make it less stressful for you is have 4 Jupyter notebooks ready to go, 1 for each problem, let's say, and you will implement it in your Jupyter notebook. And then also for your Word document, your Word, Microsoft Word, so that you can, if I ask you to do a flow chart for one of the problems or pseudocode, you can type it on there. All right, so I'm not gonna do like text boxes in Brightspace where you type stuff in there. Instead, I'm gonna ask you to do a Word document, your Jupyter notebooks. You will zip everything of your homework. You need to name it appropriately, like homework, John Smith homework, exam 1. And then you're gonna zip that in. So what I would say is I'm gonna start the clock and I'm gonna say at 1:40, guys, this is the end of the exam. I'm gonna sign off, but I'm gonna give you that extra 20 minutes to go ahead and submit on Brightspace. And that will be the plan for your exam 1, okay? So we're gonna do it that way. So I had a question. Okay. Guys, if you have any questions about the class or any issues like that, please send me an email. That's the best way that I can reply. So anyway, so the exam is on Tuesday. I've given you the format already. I've asked you to have your Word document for flowcharting and pseudocode and to have your Jupyter notebooks for the exam. And I've already indicated that I'm going to post on Brightspace a few problems that I'm going to ask you to work on. Is it okay if we do not use Jupyter Notebook? If you do not use Jupyter Notebook, it's okay, but I still need to see your code very, very clearly. And I need to see in your Word document screenshots with evidence that your code is running. Now, keep in mind, if you don't give me a Jupyter Notebook and if you just give me code, I'm not gonna run it. So you lose that advantage of me really quickly maybe spotting a little error, okay? But you're free to, if you'd like, to use some other source. Just remember, I need to see not just the code, but the code running. I need to see that you made the effort. You didn't just write the code. We always, logically, we write code and we think, no, this looks right. Right? And then when you actually run it, boom, it doesn't run. And you might, sometimes you say, well, he can just put the floats and that's it. And that's true for these problems. But if you get into that really bad habit, later on, you're going to realize that you're doing code that you think is logically correct, but it has 20 or 30 little typo type errors. And so nobody's going to debug your code, right, but yourself. All right, so definitely please be aware of all of that. So that's the plan for the exam. Are there any questions about the exam 1? I'm not sure how much it's worth of your grade. I can't, check the syllabus, of course. It's there. I don't remember. Probably like 10% of your grade, but definitely check. And we will have 3 of these exams. So exam 1 at week 6, exam 2 at week 12, and then the final exam during finals week. Questions? No questions? Given
Actually, how many questions did you say it was gonna be?
it depends, right? But it's probably going to hover around 4 questions. It could actually be 5 if I find, shorter because of time constraints, right? You're only going to have an hour and 40 minutes. I really need to give you problems that you can do within that time period.
Okay.
Okay.
Just like the homework, it's all in one report.
Yes, please, only one report going forward for everything. Now, as far as code, obviously you can have multiple Jupyter notebooks if you want. You can put them in different folders. I don't mind, but please just have one report because, if I open that one report, I can quickly see everything. And I just like to have one thing that captures the entire homework assignment, screenshots and everything.
And it's okay to have a screenshot of the Jupyter notebook with the code running, or do you want the actual link to the Jupyter notebook so you can actually make changes?
You can provide the Jupyter notebook in there in both homework and exams. You can provide screenshots of the code and the Jupyter and the output of the Jupyter notebook. Just keep in mind, if you didn't do it right, the only way that I can quickly make a fix is in the Jupyter notebook itself, right?
Okay.
That's all I'm saying. At the end of the day, if you provide the report and everything is right and convincing, you'll get full credit. But everything has to be right. Like I have to see that the code ran, I see the output looks right, I check the code, looks right. I mean, I'm not gonna take off points if you don't include the other things. They're there, as I keep saying, they're there to help you, to make your case for your homework being complete. All right, any other questions, guys, about the exam?
Yes, I have a question.
Yes, please. Go ahead.
How do you actually turn in like a Jupyter notebook? Like how do you turn that in? Like how do you put it into a zip file and stuff like that?
You don't know how to do a zip file? You have to create a folder, put everything in it, and then zip it. Is that your
Okay.
question? How to do that?
Yeah.
Okay, so what I'm gonna do is shoot me an email about that, and I'm gonna copy Mitch Burke, remember the TA for the class, and I'll ask Mitch to see if he can create a very short little video on how to zip your files. Okay?
Okay, thank you.
Yeah, no problem. But send me the email, please, so I can do that. Any other questions? All right, so it seems like everyone is clear. So please, remember exams are extremely important. Do not miss an exam. They're individual work. They're not team efforts, right? So make sure you don't are working with other people. You should do things individually, and I'm sure you guys, are not gonna do things like that. All right. So anyway. So given that we have talked about, we've done a lot of examples today, we have an exam next week. So probably this chapter, you won't have a new homework assignment this week, given that I'm going to give you instead time to study for the exam, to prepare. So, but I'm going to start repetition structures today. I'm going to do examples of them on Thursday. And then after the exam, I'm going to continue with them, wrap them up. And so the assignment for this repetition structures will be assigned on the Thursday of week 6. Okay, so no homework this week, but instead work on studying for your test, maybe create a cheat sheet, however you study and prepare for exams. Okay. All right, so let's begin. These are very fun things to do. right, so I'm sharing. Are you guys seeing the slides right now?
Yeah.
Okay, great. All right, so let's then get started. All right, so repetition structures, commonly known as loops. Loops. Looks terrible, but loops, right? So that's oh, I'm in slides. Yeah. All right, loops. All right, there are several types of loops that we can try. Usually the most common one is the for loop. And as I said, repetition, you know, they're called repetition structures. Other people call them iterative structures. Just like with decision structures, I was probably using the terminology conditional structures. You know, they keep changing the names, but they're the same thing. All right, so the repetition structures or iterative structures are really the power of Python or of programming in general, right? So most programming languages, you know, they're if statements or conditional structures, loops, arrays, and object-oriented. And then after that, you know, there's other things, but these are the key factors. Now, there are other ways of processing data, but this is at the heart of computing, especially for CPU programming. Whenever you're using your central processing unit, CPUs like your Intel and AMD, they are essential. Okay, so the topics that we will cover, quite simply an introduction, a light introduction today. I'm not gonna go, you know, given that we don't have much time left today, just very easily, you know, kind of go into repetition structures, you know, the while loop, right? Which is called also a condition controlled loop. And you'll see why that is. You know, it's basically, they're all repeating things, but they all do things in a certain way. The for loop, which is a count controlled loop, okay? As opposed to a condition controlled loop. So the while loop is like saying while true or while false. Whereas the for loop is, so it's more like do loop from this to that. Okay. Then using loops, we're going to consider how to calculate a running total. All right. So we're going to start to see how we can do repetitions more efficiently. Then we have sentinels, right? We'll talk about that, how we can kind of stop a program. Then we have input validation loops. So we're going to start looking into the idea of input validation, which is so important for security. So for those of you that, you know, love security, you know, Python is actually widely used for that. And, you know, there's a lot of other tools that you can learn. But in programming in general, you know, input validation is like the simplest thing. And actually one of the most important things, even though it's so simple, for security of your code, software assurance, as it's called. And then we're going to look at the famous nested loops, all right, that give us even more power to do things, you know, with our program. So very, very exciting topics. All right, so trying to move this. Okay, there we go. So introduction to repetition structures. You often have to write code that performs the same task multiple times. You've seen that already a little bit with modular programming, right? So in modular programming, you were you know, you didn't want to write a whole bunch of statements, 1,000 statements if you're repeating them. So you try to find patterns in your code that you can break down and reuse code. So in the for loop, it's kind of the same idea. You don't want to perform the same task multiple times, so you can write it with for loops. You know, there are disadvantages to duplicating code, right? So make programs large, which you don't want. It's time consuming, may need to be corrected in many places. All of these things are true. So initially, for instance, I like when I'm learning something new, I think when we are all learning something new, we like everything very explicitly written, even if it's longer and bigger. But you do that, you understand something, you get it to work, and then you start doing efficiencies. You start improving this part of the code, it starts improving that part of the code, and eventually you end up to code that it's a little less readable per se, but it's much more efficient, right? And so that's the idea with for loops. And at the end of the day, sometimes writing it with, you know, these, although it might seem more confusing at first, once you really get a clear understanding of it, it's actually more readable, more clear. So that, you know, it's kind of a, there's a trade-off there over time. The repetition structure makes computers repeat included code as necessary. It can also include conditional structure. So now we're actually mixing in sort of if statements within loops, because loops have the if state. We don't have to explicitly write an if, but loops kind of have that implied within them, and so we're actually it's a much more powerful structure than before. Excuse me. So let's start, I guess, with the while loop. So the while loop is a condition-controlled loop. While loop, while the condition is true, you do something. Okay, and while the condition is false, you know, when it is false, you stop. So two parts: the condition tested for true or false value, so you need to have that in there, and then the statements that are repeated as long as the condition is true. And then, of course, there's the way that we write it in a flow chart. The idea is that the line now, it's still the same flow chart, but the line goes back to the previous part. Now, the general format, as you can see, of a while loop is like that. So you have while, right? And then you have the condition. For instance, you know, let's say, you know, x less than or equal to 20, right? So as long as x is less than or equal to 20, you do something. So the statement would be maybe print x, and then you do x equal x plus 1. So what do you think is happening here? Initially, though, you have to initialize x to something. Let's say 0. So what is this, what I just wrote, what do you think that's doing? What is this code doing? Who can tell me?
Wait.
Huh? What's it doing?
So it's just gonna print X until it reaches over 20, right?
Yes, that's correct. What's happening here? What's this one doing?
To add an X to 1.
So we're incrementing it, right? Every iteration is changing. So now tell me, the output of it, I want the output of it to look like this. Currently, the output will be 0, 1, 2, right? ... But let's say that I want it to look like this. 1, 2, 3, all the way to 20. Will this do it? Will this give me that output?
When eventually you could go over 20?
Will I go over 20? It'll get to 20. It'll print to 20, right?
Yeah.
So let's go back to the original. The first iteration, it prints 0. And it's going to print all the numbers, 1, ... all the way. Does it print 20 as well?
Yeah.
Okay, it prints 20. What about 21? Does it print 21?
No.
No, right? Okay. Now let's say that I give you a exam type question and I say, I want you to change this code to print from 1 to 20. So 1, 2, 3, ... 20, and just that. How would you change the code to achieve that objective? Who can tell me that?
So you say if X is less than or equal to 20,
Okay.
print X.
Mhm. But the problem is currently it's going to print 0, right? And I don't want to see 0 in there. I just want it to print 1, 2, 3 to 20. So how would you change the code? So what I'm saying is that as it currently is, it goes from 0, 1, 2, ... to 20. But I don't want this one. I want this one. So I need to make some changes to this code to achieve that. What would you do? Nobody?
It's just a guess, but would you put 1 to 20 instead of
Say it
0?
again. I couldn't hear you.
It's just a guess, but would you put 1 to 20 in place for 0?
Unfortunately, your communication is not very clear. I couldn't make out anything you just said. Did any of you understand what he said?
No, it was really laggy.
Yeah. So I'm sorry. I can't understand what you said. We just need to. I'm only asking, how do we modify this code to print from 1 to 20? Just that range of values. So what do you guys think?
Can I say while X is greater than 0 and X?
Okay, I see what you're saying. You're right. You're right. That's very correct. Yeah, you answered my question actually. Not the way that I wanted you to answer it, but you did a good. Okay, so you said X, while X what?
While X is greater than 0.
Oops, sorry. Well, X is greater, not there. Greater than 0, okay.
And X is less than or equal to 20.
Okay. So what do you guys think about this solution? Does it work?
Yeah.
So if it's X greater than 0, it's not going to print 0, but it's going to print 1. And X less than or equal to 20. Yeah, that'll do it. Good job.
Thank you.
All right, another, yeah, that's it. Yeah, I guess let's, what I was going for was if X less than or equal to 20, right? What you could have done was just flip this to the other sign, print X, right? So now it won't print 0, it'll just make it 1. And when it gets to 20, right, it would make it 21, which we don't want. So if we just did that, it would make it, it would stop at 19, it would add 1 to it, and it would give us 20. Do you see that? It's just another way of doing it. You know, if anything, your example and this example kind of illustrate that there's always several ways of programming, right? There's always, you know, different approaches. Good. All right, so now let's look at the flow chart. So here we have our flow chart. As we can see, the while loop, a condition controlled loop. So you can see the while logic. Basically, we come here, we have the condition, you know, true or false. If it's false, we go in one direction, which is basically stop, or actually not stop, but exit. While loop. But if it's true, you know, there might be some statements, and then the important thing is we go back and review the condition yet again. Could I write while true, print hello? What do you think would happen if I wrote that in my program? What do you think would happen?
Wouldn't it just keep printing hello until it's false?
Until when? Until forever, right?
Forever, right?
Yeah, this is a infinite loop. You will create at least one infinite loop in your programming endeavors. All right, and an infinite loop, actually they have a place like in electronics. If you have a little toy that always starts up, right, and you write it in C++, you'll have a while true. And what that means is basically it's always running. It's, you know, doing whatever it's doing. So they do have a valid place. It's not, I'm not saying this is an error, but sometimes in the type of programming that you do, you know, in Python or C#, that kind of thing, non-electronics, you probably don't want infinite loops, but you will, you know, you will have one or two here and there. So the while loop, a condition-controlled loop, continued. In order for a loop to stop executing, something has to happen inside the loop to make the condition false. Iteration, one execution of the body of a loop, right? That's why I call them iterative structures. So the name is called, it's one execution of the body of the loop. You keep track. I usually like to keep track of things by, you know, having like an index. And then I'll say, okay, this is iteration 0, this is iteration 1, you know, iteration 2, ... and so on. Okay, but this is more of an imaginary thing sometimes in your mind, or in your, if you use it, you know, if you write down things in paper, but it's very helpful to keep track of things. So iteration, that's the terminology for one execution of the body of a loop. While loop is known as a pretest loop. So it means test condition before performing an iteration. So no iteration is guaranteed, because it could be that initially something is false, and if it's false, the while loop will not execute. Whereas the for loop, for instance, might execute at least once. So we'll never, so that here you can see, we'll never execute if condition is false to start with. Which, you know, that has a valid place, right? That has a valid place. Sometimes that's the exact behavior that you want. You know, it's exactly what I was getting at when I was doing this, right? That by placing your code in different ways, you achieve different types of behavior. Okay? So we'll never execute if condition is false to start with. It requires performing some steps. It requires performing some steps prior to the loop. You know, like initializing a variable to see if it's true or false, etc. All right, so here's an example of a flow chart for a program. So you have the start, you assign y, keep going, right? So, some value. And then you evaluate the condition. Notice that we used the same decision structures as before. We do, is keep going equal to y? So let's say it's false, program ends. Maybe it executes, some other statements, but basically the loop itself ends. If it's true, we execute another sequence of, prompts, some calculation, a print, another prompt. But then what's important is, because it's a while loop, we return back to the initial position and we execute a second iteration. So we have done 0, now we're back at 1. We go again into this, and again it's true. So we go in here, and again, and that's another iteration. Oops. Iteration 2, and so on. Right? So we are executing multiple iterations, and it's good sometimes to keep track of them by doing something like this. All right. Infinite loops, so I kind of hinted at this. Right? So we did infinite loops. So loops must contain within themselves a way to terminate. Right? Something inside a while loop must eventually make the condition false. Right? Some evaluation in the logic, something that maybe you're reading. So the simplest way to think of this is you're reading an input. So every time you read an input, you evaluate, okay, do I have what I need to stop now, or should I keep going? Okay. An infinite loop then would be, by definition, a loop that does not have a way of stopping. It repeats until program is interrupted. You kill the program basically, intentionally. And this occurs when program forgets to include stopping code in the loop. As I said, there are valid reasons why you would do that sometimes. Not, if like in hardware mostly, like if you're building, physical stuff. But otherwise, this, for you at the beginning will probably be something you forgot to do. So, some type of a programmer error that you make. Now, the other for loops. So currently we've looked at the while loop, right? We looked at the while loop, but there's another one called the for loop. The for loop. Usually, people have a tendency to use for loops more than while loops, I would say. You have a little bit more control over them, I guess, but you will end up using both of them. So count control loop is the for loop. And it means that you just have like indices in there that help you to better control what's going on. So it's like you can say, I just want to run the loop for 5,000 iterations, or 2 iterations, or 7 iterations, right? So you can, or I want to run the loop for 20 iterations, but I only want to do something when it's an even number, or when it's an uneven number, right? Or I want to do a count from 1 to 5,000, but I just want to do everything every 5th iteration. So you have a little bit more control, and you can see that here by having multiple parameters, not just one anymore, but you can build things a little bit better. So using a for statement to write count control loop, designed to work in sequence of data items. So designed to work in sequence of data items. Iterates once for each item in the sequence. All right, so the general format is going to be for variable, the word in, and then this. This is called a list, okay? A list is a type of an array in Python. And so basically, it's one of the basic structures of Python. Python intuition is that a lot of things are lists. And even the for loop, you're saying for variable in list. And so I would say it's almost like saying, imagine a bucket. And in the bucket, you have tennis balls, right? Tennis balls. And so what you're going to say is, you're kind of saying for every ball in the bucket of tennis balls. So it's like you take out a tennis ball from that bucket, okay, you do something. You take out another ball, but at the same time, you can color code the balls, right? So you could say like a red ball, green ball, blue. And so then you would say for tennis ball in bucket of tennis balls, and I grab the red ball, then I'm gonna do this. So it's sort of that idea. So there's a lot of power there with for loops, okay? But in its simplest form, it's just gonna be a range, and the range is going to return a list. Again, you know, everything always goes back, regardless of what you see in there, everything is evaluated back to a list, okay? So just, you know, be aware of that. Don't worry so much about this already. As I said, with this topic, I'm gonna take my time both this Thursday and next Thursday. However, I do want to stress that whatever we cover up until Thursday could be on the exam. So certainly pay attention to what I'm saying and ask questions. All right, the target variable. The variable which is the target of the assignment at the beginning of each iteration. All right, so we will see how that works in a sec. So here we have a nice example of the for loop. So let's take a minute to kind of think about it. So what we have here is we have a for loop where we're saying for num. Num is a variable, any name. So this could be any name. But it's the object that grabs. And so you're going to say for num in, and then you always have a list of, you know, whatever size. Right? So for num in list, do something. It's going to grab the things in order, right? In the sequence that you provide them. So for instance, here, the list is 1, 2, 3, 4, 5, right? So we have these 4 parameters in there, or values in there. So what you're saying is for num in 1, I grab the first one in the list, and now it's like it's in num. It's been assigned. You can think of it as implicitly in the first iteration, 1 has been assigned to num. So now when you print num here, you're going to print 1. In the next iteration, num is now saying, okay, this is the second iteration. For num, I already did 1. I'm going to do the next one, 2. So 2 gets assigned to num, so I'm going to print num, and this prints 2. Then I do the third iteration, got num again. This time I grab the third value, okay, I assign it to num, and then I print 3. Again, in the fourth iteration, I have num again. So num, I grab the fourth one, assign it to num, and that gives me 4. And then in the last one, I grab 5, assign it to num, and that's 5. And then here, 4 and 5. Is there a 6th number in the list? No, there's no 6 in the list. It actually ends at 5. So then the for loop finishes execution the moment it runs out of things in the list. So that's the same thing as the idea that you have a bucket, right? And it's got tennis balls. So eventually, you know, as you're grabbing them, you're running out of them. Now they are in order, really. So they would be like this. So they're, you know, you can only grab in order, but you eventually exhaust them. the list is empty. And so, because you've iterated through it from beginning to end in a way, so you're no longer using it. And so the for loop terminates. Questions? All right, so I think this is a good stopping point. On Thursday, I will come back to range because I don't want to get into range, but just review these topics for now that we have looked at. If you have any questions, on Thursday, we will continue with range and just looking at more things, right? And then, as I said, next Tuesday, you have your exam 1, so make sure you're studying for that. And on Thursday next week, we would finish up for loops with more examples, and then I will assign the next homework assignment, okay? All right, and that's pretty much it for today. If you have any questions, I'll stay for a couple of minutes to answer your questions. Otherwise, you can sign off, and I will see you guys on Tuesday.